Okay, I want you to try to graph that first equation without your calculator. Without the calculator. Okay. Remember what we talked about on Friday? Yes? We were graphing without a calculator. Do you remember that? Where would I begin here? The y-intercept, which is what? -1. Okay, so remember we have to identify our m and our b. The other ones we're going to use with a calculator. I'm just trying to refresh y'all from Friday. So my b is -1. What's my m? 2. And 2 over what? Because I have to have it as a slope. I mean, as a fraction. 2 over 1. We always put those whole numbers over 1. Everybody okay with what I've done so far? So remember, we begin at -1. So on my y-axis, I'm going to put a point at -1, not my x-axis. Everybody okay with that? Okay, and then I move up to right 1. So up to right 1, up to right 1. And remember, we can do opposite by going down to left 1. Remember, double opposite, down to left 1. And we're going to use our handy dandy ID badge to make a straight line. And remember, you go all the way across your graph, not just through your points with arrows on the end. Okay, so from there, we're going to talk about domain and range. Well, so far, domain and range have been of discrete graphs. Do y'all remember me talking about discrete dots? So when it's dots only, that's what domain and range looks like, just like the warm-up we just did. However, is this dots only? Or does this have a line? This has a line, so it's considered continuous. Yes? So when we do continuous graphs, do you really want to list all your x values if this goes on forever? No, because we would never be able to physically list them all because decimals are options. Okay, all these down here that we don't see and all those up there that we don't see. We don't want to list all that. We would be here forever. Okay, literally. So the way we do this is we're just going to say, because this one, does it go left forever? Like technically, if I keep going, is this going to keep going to the left? Yeah. Does it go right forever? Yeah. So for my domain, my side to side, it's going to be all real numbers. All real numbers. There is a fancy symbol for that, and it looks like this. Oh, it might help if you can see what I'm writing. Could be a good start. Now, for my range, same concept. Range is bottom to top. Does this go down forever if I continue and follow the arrow? Yes. Does it go up forever if I continue and follow the arrow? So my range is the same thing. All real numbers, which is this fancy R. Any questions with that so far? Okay, so in your calculator, if we were to type f of x equals 2x minus 1, that's our graph. Yes, that's what we just graphed. So then what do you notice in number 2? What's different? What does 2 add behind the equation? Anybody know the word for that? What I just highlighted? So it's an inequality. That's what those symbols are, the less than, greater than, right? Okay, those are inequality symbols. So I want y'all to type that in your calculator. So you're going to type it exactly the way you see it. Okay, so I'm going to throw in the symbol -4 is less than or equal to x is less than or equal to 3, and then the symbol again. Oh, not that symbol. Oh my gosh, what did I do? There we go. So everybody should have that typed in their calculator. Everybody should have that typed in your calculator. Let's get it out. What do you notice this time? What happened? Does this line go on forever? No, it does not. Okay, it has what we call boundaries. Yes? So from there, I'm going to use my table to help me. So cogwheel table. And didn't I say x is everything between -4 and 3? Isn't that pretty much what that means? So I'm going to type it. So -4, -3, -2, -1, 0, 3. It just puts points where we're at. So everybody's table should look like mine. So what this is telling us is that this graph has to stay between -4. Didn't that start at -4 and go all the way to x is 3? Did it pass? Did it go less than -4? No. Did it go greater than 3? No. Everything for my x is between -4 and 3. Yes? So if we graph that line, we start at -4, -9. And then we have the point -3, -7. -2, -5. It's going up 2 over 1, right? And it stops at 3. Now, I've been stressing to y'all, like on this one, to draw the line forever, right? And put arrows on the end. Am I going to do that here? Does this one go forever? No, so we're just connecting the dots. And then we stop. So what I want y'all to realize is this gave me a boundary. Okay, it said, I want this graph, but I only want it when x is between -4 and 3, right? Okay, and then it says x is greater than or equal to -4, so it can also be -4, and then it's less than or equal to 3, which is also equal to 3. So it said I want everything between here and here. Are these graphs the same? Are the lines the same? Yes, this one's just cut up, right? We only have a piece of it. This is the whole line. So from here, we only have this piece. So when I talk about domain here, again, farthest left to right is domain. What's the farthest left this graph went? What's the boundary it gave us? -4. And what's the farthest right it went? 3. Guys, this is your domain. So we write domain and range as an inequality for continuous lines or continuous data. Ooh, might help if you could see it. So it gave us our domain here. It did not give us our range. Okay, so our range, what's the lowest this graph went? Because we remember we do lowest to highest. What's the lowest this graph went? -9. So I'm going to put -9. And what's the highest it went? 5. So I'm going to leave, you see I left all that space in between, yes? And I know range is my y. And I'm going to tell you right now, we're always using less than symbols. Always less than, and these are equal to. I'm going to show y'all what do we use when it's not equal to. Okay, nobody should be touching their computers right now. Everybody should be writing this down. Okay, one thing I want you to realize is, see how we have 2 endpoints, no arrows? My domain and range has 2 numbers. Yes? Because I have 2 endpoints. Number 1 had how many endpoints? Did it have endpoints at all, or did we put arrows? We put arrows. So when there's no endpoints, there's no numbers in our domain and range. We just said all real numbers, okay? What do you think happens when there's 1 endpoint and 1 arrow? So 2 endpoints means 2 numbers. What do you think 1 endpoint means? 1 number. Okay, so that's how it's like kind of a secret with it. Another thing I want you to realize here is that sometimes you're going to see these as words. So we're going to write it down. We're not going to do it for all of them because that gets a little excessive, but we're going to write it down for a couple of them. So what this means in words is it means you're going to make sure you write up here too, all real numbers. So you read it from your letter to your number. So is this saying X is bigger or -4 is bigger? Which is the mouth eating? The X. So X, all real numbers greater than or equal to -4 and less than or equal to 3. Now there is another way you could see the range. The only difference is what's in the middle, where everything else is going to look the same. Because this said f of x for our equation, you could see it to where f of x is in the middle. And this one's going to be all real numbers, where y is greater than, so greater than or equal to -9 and less than or equal to 5. It's just a fancy way of saying everything between -9 and 5. Yes? So looking at the big picture, what changed? When we went from f of x equals 2x minus 1 to this, what changed? What happened? Good talk. Nobody. So from my blue line, everybody look, from my blue line to my red line, what happened? Well, what was my blue line doing? If I keep zooming out, does my blue line ever stop? Never stops. Okay. What about my red line? It has stops. It has stops. That sounded weird. Okay, it has boundaries. It has limitations. So when we added this to our equation, it limited it, right? It gave it boundaries. So it put boundaries on the graph. It put boundaries on the graph. Okay, this next one, we're going to talk about something first. So here we have this. On our last one, we had equal to's only, right? And when it's equal to, we use just a normal dot, right? This means that the answer is included, or the point is included in the answers. Now, do these have an equal to? No. So when we don't have an equal to, we use what we call an open dot. So this means it's excluded from the answers. If I say I have less than $2, can I have $2? No. Can I have $1.99? Yes. So that's what this pretty much means. If I put an open dot at 2, and I say everything less than 2, it's just saying I can't have 2, but I have everything to the left of 2. Does that make sense? So it's like a placeholder. It's saying, hey, everything to this point is included, but this point is not included. Because 1.99999999999, I know that can't be money, but that can be a point on a graph, is included, but 2 is not. Okay? So it's just saying everything up to that point. So if you notice here, we do have a greater than with no equal to. So what are we going to use here? An open dot or a closed dot? An open dot. So we're going to go in our calculator and we're going to type this one this time. So this time it just says x is greater than 1. Everybody should have that in their calculator. Okay, on this one, didn't this give me the boundaries for x? Okay, so this is my boundaries again for x. So I know at x is 1. I'm just going to draw a vertical line, super light. And is this saying x is greater than 1 or x is less than 1? Who remembers? What symbol is that? Greater than. Okay, everybody hold up their left hand. Do this. Left is less. That's your less than symbol. So if you ever forget, hold up your left hand. That's your less than symbol, right? Less than symbol with your left hand. Okay, I'm really zoomed in, so it's hard to tell it there. But you get it. So if this is x is greater, is my greater x's to the right or to the left? Where are my numbers bigger than 1?
Right.
To the right. So this graph is going to go this way, never this way. Well, isn't that what happened? From 1, did this ever go to the left? No, but look, does it ever stop going to the right? No. So what that means is it's going to go to the right forever. So we're going to graph it, and we're still using the same point. So watch, I can pull up my table, and I think it's freaking out because I have this one in there too. There you go. Do you see, because it said x starts at 1, what does it say? Undefined, because what kind of dot am I going to use there? Where it started. An open dot. So, looking at this graph, what point is it at 1? Isn't it just 1, 1? So guess what? We're going to put an open dot at 1, 1. And then we're following our same slope for our points. So at 2, it's 3. Isn't that the same as going up to right 1? Are we still following the same slope from the first one? Yeah, so up to right 1. Now, everywhere else we can use a closed dot. That open dot is just at the boundary. And again, we're going to draw an arrow, but only on this side, because it cannot go to the left of 1. Well, the nice thing is it gave us our domain. So we know x is greater than 1. And we also like this one because when it comes to words, we only have one boundary. So it's just, if I read this, it's going to be all real numbers greater than 1. Now we have to find our range. Remember, range is bottom to top. What is the lowest this graph goes? 1. The lowest it goes is 1. It never goes lower than here. So what symbol am I going to use? Y is greater than 1 or less than 1? Yeah, because it's going up forever. It's going to the bigger y value. So y is greater than 1. Now, remember, you could also see this as f of x is greater than 1. And then the words are going to be exactly the same. All real numbers greater than 1. Any questions with that? Okay, flip it over. So these are graphed for us, which makes our life way easier, y'all. And this is how it's usually going to be when we're finding domain and range. I'm not usually going to ask you. I'm not usually going to say, hey, here's the domain, go graph it. But did we learn that we can type it in our calculator and it'll limit us for us to show us what it should look like? Yeah. So what this is we're just going to identify domain and range. And this is where we talk about the box. Didn't we, when we drew our boundaries, make a box? Didn't we box our line in like perfectly? If you do that, it will help you. So looking here. What's the farthest left? Because remember, domain is left to right. It's our x value, so we're only looking at the x-axis. What's the farthest left this graph went? -5. So we're going to write -5. What's the farthest right this graph went? 2. So I'm going to leave all that space in between and put a 2. Is domain my x or my y? X, so we're going to put an X in the middle. We're always using less than symbols because we went least to greatest. As long as you go left to right, less than will always work. Now, is this an open dot or a closed dot on both sides? Closed, so am I going to use equal to on both? Yes. There's your domain. That's it. And this is just a fancy, I'm not going to make y'all write the words for every single time. I just wanted y'all on the front to see what the words look like. But this would say all real numbers greater than or equal to -5 and less than or equal to 2. It's both. Fancy way of saying everything in between. So for my range, what's the lowest this went? Because remember, bottom to top and ranges are y. The lowest it went is -3. What's the highest it went? 4. Now, this doesn't have an f of x or anything, so we're just going to put y. And again, always less than. And this time it's equal to. Okay, I want y'all to try number 2 really fast. Oh, I don't have my computer. Just kidding. We're going to just do it together really fast. I left my computer at home. Okay, number 2. What's different? Are the lines exactly the same? So will the boundaries be exactly the same? The numbers will, but what's different? This one has an open dot. So when we talk about x here, it still goes from -5 to 2. So -5 to 2. We still have an x in the middle, and we always use less than. Which one of those is going to get an equal to? Which one had a closed dot? -5 or 2? So this is the only one that gets an equal to. That's the only difference. I just wanted y'all to see the difference of an open dot versus a closed dot. This one had both closed dots, so it had both equal to. This one did not. So same concept for range. It still went -3 to 4. Which one gets an equal to this time? The -3 or the 4? -3 had an open dot, so -3 does not get an equal to. 4 had a closed dot, so this one gets an equal to. Okay, one more together. I want to do this one because it has an arrow. And so remember I said when it has one arrow or one dot, it only has one number in the domain and range, right? So what's the farthest left this graph goes? +2. And is x greater than that or less than that? Is it going towards my bigger x values or my smaller x values? Look at the x-axis. Starts at 2, and then it goes to the right. Those are bigger x numbers, right? So this is x is greater than 2. Does it get an equal to? No, because it's an open dot. Good job. Okay, now here's a question I have. What's the lowest this graph goes? Forever, right? It has an arrow at the bottom. So if I continue this graph, doesn't that mean it goes down forever? Yes. So do I have a lowest point? No. No. Do I have a highest point? Yes. What's my highest point? 6. So y and 6. Now, is it less than 6 or greater than 6? Does the line go lower or higher? Less than. It goes down forever. So this is less than 6. Does it get an equal to? No, because it's an open dot. Okay, I want y'all to try number 4 while I update Schoology.